Hello and greetings from University of Brunei Darussalam. I'm Afroz. I'm Senior Assistant Professor of Structural Geology, and today I'll be talking about unplanned urbanization, the transition of earthquake and flood hazards into major disasters in Kashmir, India. Before that, I would like to congratulate and thank Akita International University for organizing this wonderful session, and I wish you all the very best for having a great time here. So the work I'm sharing with you is a collaborative research. As I said earlier, that I am actually associated with Faculty of Science, University of Brunei Darussalam, and I also head the program for geosciences. Now, in terms of the earthquakes and floods, we have two major, well, I would say, the hazards in most of the collision zones. So in Kashmir, which you can see from here in blue color, is a basin. It's a very beautiful basin surrounded by mountains, often called the Switzerland of Asia. So, but with that beauty comes the beast, and the beast is, in terms of the hazards. So we have hazards associated with, for example, this red line is the major fault because it's the plate boundary fault um, between India, which is on this side, and Eurasia on the other side. So in other words, we are actually more or less at exactly at the boundary of the two tectonic plates. They are interacting. India is pushing to the north, and because of that push, you're constantly building the mountains, Himalayan mountains, and those building of the mountain comes by um, what do you call it, Virtude? It comes as an earthquake. So most of the building of the topography is created during earthquakes and folding. So the earthquakes often are actually quite damaging. So if the magnitude is more or less more than 5, it causes damage. And later I'll tell you, I mean, how that happens and why even the small earthquakes are causing trouble. So the red dots that you see here are major earthquakes that have occurred in this region. Therefore, the point I want to make is this: the flood hazards and earthquake hazards are genetic to the structural setting of this area. So we cannot do anything in terms of stopping it. The reason is simple because they are genetic. You cannot stop earthquakes from coming, and you cannot even stop floods from coming. The reason is because the floods are also associated with topography. One is like, okay, because we are surrounded by the mountains, so all the river systems that are generated there, they come and they can actually cause really bad floods in this area. The only thing that we can do is basically live with earthquakes, live with floods. So that is something that we have to understand how to live in harmony with the hazards, and that's something that would like you to understand. If we really want to do something about the hazards in this area. Okay, great. So now, in terms of the geological setting, in terms of the rock types, as you can see, the Kashmir is a basin. As you can see here, the white indicates it's a very young basin. We know from the geological record it's 4 million years. And this Peshawar basin is similar to 2 to 3 million years. So they're very young basins, and the basins have formed very during the collisional orogenesis. In other words, this collision continues, and this has formed this basin, which is typically what we call in tectonic sense. This is a piggyback basin. So therefore, the basin will have another problem, which is because it is filled with sediments, and most of the sediments are water saturated, particularly where there are river streams. So, for example, there's a major river which goes through the center of the basin, and that is going to cause a liquefaction. And you can also understand, because this is mostly mountains, so that's we will have an additional hazard of landslides. So the Kashmir is basically surrounded by all these hazards. So you have earthquakes, you have floods, you have landslides, you have the problem of liquefaction. And therefore, all these hazards have surrounded this Kashmir basin and made it one of the, I would say, the vulnerable areas in this region. And that takes us to an important understanding about this. This is a collective challenge. So the challenge is that we, all of us who are here, we want to save people, we want to help people, and for that to do, we need to understand how we're going to do that. So we have more or less spent almost 2 centuries of scientific wisdom that, as I said earlier, the earthquake, the knowledge about that earthquakes are going to happen, it has a long history. More than 2 centuries of scientific wisdom is available, and you can more or less let's say that at least one more than 100 years, from more than 100 years, we know that how to save our lives from earthquakes. So we have to just build structures in such a way that the earthquakes will not cause the structures to fall, and that's going to save life to a large extent. And similarly, the flood hazards, wherever the floods will occur, we have to make sure that there is enough space for water to flow so that we're not really going into these hazardous zones. But the problem is that we still have we're occupying most of the hazardous zones. At least I will in Kashmir and in the areas where I have worked, for example, in most of South and Southeast Asia. Um, Wherever you go to Bangladesh, you go to India, you go to Pakistan, Indonesia, you will see same story. So that's why it's a collective challenge for all of us to understand why are we not following procedures, which are basically quite old. So here is an example, and you already know about these some of these major earthquakes that have happened in the past. We have an Indian Ocean tsunami of 2004, which caused enormous, damage in terms of economy and life. Um, so that tells us, was there no precedent of the 2004 tsunami? No, there was. We have a lot of data which clearly say that in the past the tsunami science was dead in a way, because tsunamis were there, but somehow the science was under the carpet. The reason was, I think, because we have um, very, the humans have very short-sighted memory, and for that, the problem is, okay, you got an hazard, and if the time between two hazards, two earthquakes, is quite long, right? The interseismic period is long. We just forget about it. So we say, okay, there's no problem. And I think that's something that we need to worry about. So same thing we have seen number of these deadly earthquakes. For example, this particular earthquake, which is very close to where I work, 2005 Kashmir earthquake, it killed 2005. It killed 86,000 people, and the magnitude was 7.6. So we had, for example, magnitude 7 to 7.1 in the Afroz earthquake in Christchurch in what do you call this, New Zealand, and there was no loss of life. And you can see the magnitude 7 in Haiti, and all of you know how much of the hazard actually turned into disaster, because the Haiti has other important issues to consider. So now, when I put this on a, on this graph and show you, like on a plot, and show you like, okay, let's try to understand, if you have the same magnitude earthquake, why do we have so much difference in terms of how the hazard turns into a disaster? So the magnitude 7, there was no problem in New Zealand. There was no casualty, but you can see same magnitude has a huge problem in Haiti. And that is a very important realization, that particularly areas where there are no preparations for earthquake hazards, unprepared nations, they suffer the most. And those unprepared nations will have, for example, there can be a problem in political system, there can be a problem in administrative setup, there can be a problem in economy. So all these things come up, they add up to the story about the hazard turning into disaster. So the disasters happen mostly because of we as humans do not take action before. And wherever the actions have been taken, for example, in Japan, in US and parts of US and New Zealand, we have seen it actually results in the decreasing the tendency of the hazards to turn into disasters. So now, that was a portion about the earthquakes. I mean, you look at the floods. This is a flood in 2014. It was, as you can see from here, more or less whole of the Kashmir Valley, the core of the valley was inundated with water, as this is the actual flood, that happened. Now, the flood hazards again. When we look at if you remember, and when I started, I said that this is prone to floods. The reason is simple because Kashmir is surrounded by the mountains. Therefore, there's only one major stream, and you can expect why, because you've got mountains here, all the water drains here, and collects in this stream, and then you know that stream takes it out. So there's only one stream takes it out the whole water, and it can easily get filled. So ideally, all of that close areas that are close to the stream, they should not be urbanized. And the reason is simple: or if they are urbanized, there has to be taken into consideration that there will be a flood, and the level is going to go up. So you make sure that the areas are set like you're making these building in such a way that they can, just like what Netherlands has done, so the water can actually fill the space, and your house is going to go up along with the water, and you will have no problem in terms of the hazards. But as you can see, that was not done. So here is showing the topography. Uh, this is an important understanding about how topography is very important, and it actually impacts how the flood hazards are going to run. And this is something that we have recently discovered. Most of the studies they were concentrating about only about only about, for example, how much water is coming in other words, precipitation was the main factor. This much water comes and floods. But if you really understand why this area, for example, has a lot of inundation, while as this area has less, then you realize it's actually topography plays a critical role about how the water will flow into this, and which area is going to have more floods, and why. Okay, great. Now, something extremely important is this. It was Sir Walter Robert Lawrence, and he has written a book, The Valley of Kashmir, so in 1895. So it's more than 100 years of science wisdom. Now, what was it? It's unfortunate that the Srinagar should have been built on its present site. It's not only exposed to the constant danger from flood, but it itself is the cause of floods. Now, why was a person not really related to geology or science? He was actually an administrative a person who was administrating, what do you call it, at that time. This is during the British time. So he realized that this is a water, because he understood, has read about geology, and and so understand that, well, this area is actually a floodplain. There should be nothing in this area. So why do they put these urbanization, or even the centers of urbanization on that area? So in other words, they're occupying basically the place where the water was supposed to go. And so therefore, the simple reason is that unplanned urbanization, and it has been going on from then till now. I mean, science says you shouldn't be doing it, but it's not working, because on ground things are as they should be, right? As they should not be, basically, and that's the problem that we're having there. So therefore, what we have learned so far is that Kashmir has little um, planning for minimizing flood-related disasters, and it will be challenging to do so in the future, as most of the human settlement regions are located in the floodplains. um, More than 100 years of science wisdom have not been used. This is something that we have to be worried about. Also, Kashmir is a zone, it's a conflict zone. You have heard about it. So in conflict zones, it's very difficult to basically do the mapping and to understand it. It actually creates another problem. So there is actually a dimension about conflict-related issue, which also has created trouble in making sure that the flood disaster procedures could be established, and we should be looking at that as well. So, so the flood and earthquake hazards in Kashmir are primarily human disasters. So this is an example. This is something that we need. Now you can look here, urbanization, unplanned urbanization. So this is the water, and this was the stream I was showing. That was the stream which got flooded during 2004, and you can see what's going to happen if there's another flood. The areas are basically built areas in the whole of this area. Number one. Number two, this area is also prone to earthquake hazards. So all of these buildings are prone to basically a disaster. There is no planning. There is no earthquake resistant structures in Kashmir. Number one, and there is no planning for basically that they will establish. They will do something retrofitting or something. There's nothing on ground at the moment. And plus, because this area is prone to liquefaction, that is something that really worries me a lot. If there's an earthquake tomorrow, because of the liquefaction, the whole area is going to be in big trouble. So that's something that is worrying. Okay, great. So when we did a little bit mapping, like I'll show you some of the examples of that, because whole of the Kashmir is like that. Previously, we used to have some of the buildings which were actually more or less better built in terms of withstanding earthquake hazards. But I will be showing some of the examples and to highlight that because I have got some few minutes. So this is urbanization, as you can see, buildings more or less everywhere. And these are examples from Srinagar. So the examples of new red filled circles and old blue. So there are old buildings and new buildings, right? So the red circle indicates new, and these are the old buildings. And I'll show you examples of that. These are the modern houses. So here, for example, these are the modern houses. So what we have, all these houses that you see here, they look really beautiful and nice, but the only problem is they cannot withstand earthquakes because they're not built to withstand. If there's a shaking, magnitude 6 and above, they can easily break. So that is a big problem. And these were old. So the if you look at the difference between the new and old, here we had what you call the Daj Diwali style of construction. They used to build these, they used to actually, there was a structural integrity in these buildings. In other words, you can see that, for example, here, the buildings have built in such a way that it can withstand, like it can basically withstand shaking and behave like a coherent block in comparison to this. This one is old one, this young new one, and this is the old one. So you can see the difference. See here, you have a lot of these, the Taj Diwali style of construction, but here we don't have it. Now these buildings are more or less rare in Kashmir. You can't really see them nowadays, and main thing is because they used to build using the timber, and the timber is very expensive. The wood is very expensive, and that's why they're now constructing using the using the concrete, and which has created more problem for area which is going to be under earthquakes, which will have huge problems for earthquakes. So, and we know that there will be cascading nature of the earthquakes and associated hazards, which includes liquefaction, lands, the floods, landslides, transport disruption, and so on. Okay, great. So now to conclude, what we have learned so far is that the building designs and structures are not ready to face earthquakes and floods, and the impact of liquefaction is an additional serious concern that can be very risky in highly urbanized areas. Our data show that large clusters of urbanized areas are at very high risk of flooding and liquefaction during the projected seismic events. So we know that there is an earthquake. So the field data suggests that the rare instance of Daj Diwali style of construction, which considered relatively stable during earthquakes, modern designs do not follow Daj Diwali Daj style, suggesting retrogressive approach in dealing with seismic hazards over the years. So it questions the usage of scientific wisdom on the ground and highlights an immediate need to inspect buildings, grade them according to the regulations of the seismic resistant codes in the tectonically active zones of northwestern Himalaya. And so there is an urgent need to audit built environment to prepare for the hazards. And thank you very much, because more or less time is fixed. So if you have any questions, I would be happy to answer. Thank you very much.